It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farming Junior Nice Coffee.
Hey guys, hi and welcome to the first of my YouTube videos for my Year 12 chemistry class. In this one I'm going to be talking about how to write just some basic chemical formulae, stuff that you really just need to be able to do really simply and quickly. So I'm just going to start off by picking just some really simple ones to write. So I'm going to start off with some magnesium, which is Mg2+, and I'm going to bond that with, say, a nitrogen atom, which is N3-. Okay. So what you do when you're looking at writing formulae like this is pretty straightforward. Always follow these same steps. Number one, write the two atoms right next to each other like that. Okay. What you do is you take the number that's on the top of the cation. So a cation is a positively charged atom. Right? You take that number and you cross it down to the bottom of the negatively charged one. Here's the negatively charged. We call this an anion. Okay? Anything with a negative charge is an anion. We take that number and bring it down here to be a 3. Okay? So this formula, we write it Mg3N2. Okay? Just straightforward like that. Just swap them over. Alright, we get rid of the charge. We always should have no charges showing up the top, and the numbers are always subscripted down the bottom. Okay? So let's look at another one. Okay? If we take aluminium, Al3+, and we go with a chlorine, Cl-. Okay? Now in chemistry, just like in maths, we don't write ones, so there's actually a 1 in front of that negative charge there, but we don't write it. So following the same principle, we write the two atoms next to each other, so Al and then Cl. Okay? We take the positive charge here from the cation, we take the 3, bring it down here, okay? And then we look at the anion. Now up here for the anion, remember there's actually a 1 in front of that which isn't written, so we take that down to here and that becomes a 1 in there. But when we write the final formulae, we don't show the 1, so it becomes AlCl3, aluminium chloride. That's our final formulae there. Don't write the 1s in. Notice again, no charges up the top, all the numbers are subscripted down the bottom. Now, so pretty much you can write most formulae like that when you have an anion and a cation. What I recommend is that you use the anion and cation sheet that I've given you. You put that up somewhere, you just try and memorize them, but you use that all the time. Just stick on the back of your toilet door like I've talked about. Just try and learn it, okay, off by heart, because there's no substitute for that for chemistry. Okay, be able to just write these formulas really quickly, follow that crossover technique, and you'll have no problems. Now one thing I will introduce for you is what happens when we have what we call polyatomic ions. Okay? Polyatomic ions. Polyatomic ions comes from two words. Poly means many, and atomic, so atoms. So it's many atoms. And of course, an ions are charged atoms. So what we're looking at are charged atoms that are made up of many different types of atoms. So there's lots of examples of polyatomic ions. We've got commons like carbonate, CO3, 2-. Alright, you've got hydroxide, OH with a 1-. Now normally you notice here we've got the negative charge over by the oxygen, right? Because that's actually where the negative charge is with the lone pair of electrons, but we'll cover that in another video. Okay, you've got phosphate, PO4, 3-. Okay, you've got sulfate, SO4, 2-. So all of those are cations. They're all polyatomic because they're made up of more than one atom. Okay? You can have others as well. You can have positively charged ones like ammonium, NH4+. Okay, or hydronium, H3O+. All of those are polyatomic ions. They've all got charges. So the question is, how do you use these when you're writing the formulae, seeing as you've got more than one atom? So what I'll show you to do is how we actually do that, and we do it by introducing brackets. Okay, so for our polyatomic ions, I'm just going to take magnesium again, which is the first one we started with, and I'm just going to react it with the nitrate ion, or combine it with the nitrate ion, just like that. Okay, same principle. spell the N to begin with. You write the species next to each other, so Mg, and then you put the nitrate in there too. Okay? But because it's a polyatomic ion, what we do is we put brackets around it when we bring it down here. Okay? Very important to do, otherwise you will change everything if you don't put the brackets in. So again, we take the charge from the cation, that comes down here, it becomes a 2. We take the charge over here from our anion, which remember there's a 1 there, so that 1 comes down into there. Okay? So you still follow the same procedure, cross over your charges, but what we do again is we don't write the 1, so it becomes Mg, we leave the brackets in, it becomes NO3, 2, magnesium nitrate. Okay? So I'm going to show you another one. This time I'm going to take the sodium atom, Na+, and I'm going to combine that with phosphate, PO4, 3-. So I write them next to each other, Na, and I put the phosphate polyatomic ion in, and I put brackets around it. Crossover. Alright, so plus, the 1 plus there, comes down here, so we put a 1 in. Okay, the 3 from the anion comes down to a 3 there. Okay. But this time you'll notice the 1 is actually here with the brackets, so it doesn't change anything inside of it. So when we actually write out the formula, Na3, because there's a 1 there, we can actually get rid of the brackets. It becomes just PO4. So that's sodium phosphate. So if there's a 1 outside of the brackets, you can get rid of it as well. I'll show you one final example of where the charges actually match up the top, and that makes writing the formula really, really simple. Okay? So if you take a calcium atom, Ca2+, and you take a carbonate, CO3, 2-, okay, you can write them next to each other like that. Now, normally we'd put the brackets in and we'd go from there, but what I want you to look at is because we've got a 2 there and a 2 there, those are equal. Okay? Equal charges cancel out straight away, so all you have to do is leave it as Ca, CO3. Don't need to do anything else than that. No brackets, no nothing. Okay? And that's really simply how you write formulas. Hope that's helpful. Go practice, try as many as you can, just practice writing them all, and make sure you can actually name them as well, and that's where that anion and cation sheet comes in really handy. Look at the 2 parts of it, look at the positive part, the cation part, that goes first, so calcium, look at the anion part, carbonate, and you name it. Learn them, particularly the ones like phosphate and sulfate, nitrite, so just the difference between them. Okay, you've got NO2-, NO3-, okay, that's nitrite, okay, this is nitrate, okay, N by itself is nitride, okay, so it's a 3-. So notice the difference in the naming. If it's by itself, it's IDE on the end, and then the 2 of them, whichever one's got more oxygen in it, becomes ATE, and the one with less oxygen becomes ITE. Exactly the same when you look at the sulfates. S2- is sulfide. Sometimes you'll see with a pH as well, exactly the same, doesn't matter. SO3 2- is sulfite, okay, with an ITE. SO4 2- is sulfate, more oxygen than that one, so it gets the ATE on the end. Learn the names, practice writing the formulae, you'll get it in no time.